before we start with scalars and vectors, yesterday we have already discussed some basic things. So we are just going to start with the topics. Okay. So yeah. So in general, when we talk about vectors, we more or less are acquainted with these things like displacement, vector, velocity, acceleration, force, momentum. Well, these are not the only things that we actually have. We have many other. Let me just take probably a laser point. Okay, I'll take it this. Okay, I can use a highlighter. Okay, so we have this. So what happens is if we are actually deriving a relation which is actually vector dependent, the relation will actually have a vector quantity involved. For example, yesterday we heard about acceleration, right? And then we talk about force is a component of mass and acceleration. Momentum. What is momentum, by the way? You remember? Mass into velocity. So since we have velocity there, so we are actually more or less talking about the momentum. Okay. So if we just go for like scalars here, okay, we basically have the displacement is replaced by distance, velocity is replaced by speed, and acceleration. Obviously, it's not replaced by anything, but we have other quantities like temperature, mass, energy, and time. But in general, if we call mass and we take weight is also a force, right, which is acting vertically downwards. So basically that is an example of another vector quantity. So then energy, time, these are all scalars. Okay. So what happens is if we actually want to describe a vector, we need actually more information than to describe a scalar. A scalar is nothing but just a simple value 5, 10, A, B, C, okay, without any direction. That's why like vector becomes a bit more complex. Hence the equations or the geometrical representations are more or less different from scalar. They have the information of scalars, but at the same time you have to give them directional information, right? And based on this, actually a lot of maths gets involved in case of vectors. Okay, so this thing we already discussed yesterday, that whenever you are actually checking your book, you'll basically have two kinds of symbols. One is basically a bold font that you have, okay, for vectors, and the other one is usually a arrow will be there in case of vectors. So mostly the books are using this bold A. So we will always show vectors as arrows. So if you look into these, okay, if you look into these or this, all these are say equal length, right? So if they are equal length, that means all of these vectors are more or less equal. And very important point is if you just draw a line, that is not a vector. A very important thing is you need to put an arrow there. So if you are putting any kind of arrow pointing in the direction, it will basically show the direction of the vector. We will see the important thing in a few moments now. So in general, when we actually want to find out what is the magnitude of the vector, yesterday this also we discussed that we usually take the vector and we actually represent it with two mod signs, right? Two straight lines. So that means you are only considering the magnitude. Okay. So how it is that applicable, we are also going to see. But always remember, whenever you are using a mod sign, we also call it as the absolute value. This is always positive. So what happens is sometimes there are some trick questions and those kind of questions which might come up. So these things can only be solved if your basics are clear. So whenever you are considering a magnitude, whether it is in the positive direction or in the negative direction, the value will always remain positive. And what does magnitude represent? The magnitude usually represents this. So if you consider something like this is the length. So that means let's say it is 2, and let's say it's a measure of distance. So let's say it's 2 meters. So that means 2 meters is the magnitude, right? On the other hand, if you take another a with it, so a plus a would be 2, it will become 4 meters, and so on. So that is how magnitude usually represented. So let's go into some important properties that should be known. One first thing is basically called the equality of two vectors. So if you are basically considering two vectors which are equal, okay, so you can see all of these vectors which are there in this diagram are equal. All of them are actually having the same length. Forget about the direction, at least in magnitude they are actually equal. If you look at their alignment, all of them are parallel to each other, right? But please remember, if they are parallel to each other doesn't mean they are in the same direction. Since the arrow is in the same direction, hence they are in the same direction. Okay, so it is important. So basically they have got the same magnitude and they have got the same direction. So movement of vector in a diagram. So if you basically consider any vector can be moving parallel to itself without being affected. So what happens is, if this is a vector A and suppose after a point t it has moved at this particular point, that means it's moving in the same direction, right? And the length has also not changed. So it means that the vector has not been affected either in magnitude or in direction. Okay, that's what is meant by without being affected. Now there is a term or concept which is called negative vectors. So what do you mean by negative vectors? So if you have a vector in one direction and another vector in the opposite direction, they are basically negative of each other, right? So if you remember yesterday we actually did this. Okay, what we did was we draw this vector in this direction and then we draw one more vector in this direction. Okay, this might be A, okay, and then this might be B, and they are in opposite direction. Okay, so that means this vector B is negative of A because they are in the opposite direction. Okay? And if they are in opposite direction, the angle between them will always be 180 degree, right? So if you can look into this vector, this is a vector A, this is a vector A, and this is only another vector. Both of them are pointing in the same direction and they are parallel to each other, right? So if they are pointing in the same direction and parallel to each other, that means the angle between them is nothing but 0 degree, right? But on the other hand, it's a possibility that they might rotate, right? So now if the vector, now see the vector has rotated in the opposite direction, right? So that means it has made a 180-degree turn. Okay, and hence this is basically nothing but a negative vector. Okay, so if you look into this particular thing A, if you look in terms of magnitude, you see that A and B are equal in length, right? But now they're opposite to each other, that's why there is a minus sign, right? So in general we can say that A is equal to minus B, or we can take this A plus of minus A. That means the resultant vector will become 0. What does it mean by plus or minus A? Because I can consider A plus B. What is the result? Okay, I can find out what is A plus B, but you know that B is equal to nothing but minus of A, opposite of A, right? So I can put just A plus and then there will be a minus A. So it will be A minus A, which is nothing but 0. Correct? Yeah. So this is what is negating the vector. Basically what happens is, if a vector moves in one direction and then there is one more vector which is moving in the opposite direction, the resultant will be less. And it means that it basically depends on what kind of angle we are talking about. Okay. So let's say, for example, let's say force. Now force is basically a vector, and suppose you are dragging or you are pushing a box, okay, with some force, let's say 5 Newton. And then another person comes from the opposite direction and pushes the box with a force, let's say 2 Newton. Correct? So the box is obviously going to move a bit in the backward direction also. Correct? So then what is the total force acting on the box? It will be nothing but 5 minus 2, which is 3 Newton, right? You can understand that, right? It's very simple. So you have the box, one is pushing here in this direction with 3 Newton, the other person is pushing in this direction with, okay, let's say 1 Newton. So it will be 3 minus 1, which will be nothing but 2 Newton net force. So basically it depends on the angle and the direction in which the vector is being applied. So if you consider vector, a negative vector is also a very important concept. Okay. The next thing is how do we add vectors geometrically and so on. Okay. The concept is actually simple, but only you have to consider the direction, the initial point and the final point. Okay, these are the two things. So what happens is a body, let's say you are going from one point to another, let's say from point A to B. Okay, so let's say if you are going from point A to point B, and then obviously you might not follow a straight path if you are in a real life condition, right? So you are following this actual path, but your net displacement is from A to B, which is straight. right? So that means that is more or less the vector that is representing your displacement, right? On the other hand, you go to B and then you go again back to C. So then also there is an actual path which is being followed, and based on that we can actually draw a vector which is basically this straight line, correct? So what happens is you are going from A to B and B to C. That means your net displacement is basically from A to C, correct? This is something which you already know, right? But then why it is important? Because now we are going to represent everything in terms of vectors. Okay. So what we do is when actually we add vectors, that direction must be taken into account. Okay. So when we are adding vectors, their direction must be taken into account. Okay. And of course the units must be same. So it's not that once you are measuring length and the next moment you measure mass or weight. Okay. So if you do that, then you cannot say that this is basically a vector. Okay, vector addition. Vector addition means you are adding the same quantity more or less. Okay, and then there are different methods to do that. There is a geometric method. Okay, and then there is an algebraic method which we are going to see. Okay, so this is important. So geometric method, and we are going to see algebraic method. Okay, just a second. Huh? Okay, so what we do here is basically we are going to look into the geometrical method and the algebraic method together. Okay, so what happens is that algebraic method is sometimes more convenient because every time we don't draw things, we actually deduce from the mathematical relation. So that is something which we're going to see. So if you just look into here, that if we go from A and then we go to B and we go from this particular point directly, then we can actually represent it as, right? So in simple word, it means that S is actually a representation of the motion from A and B, right? In terms of A and B. So basically all these are nothing but vectors, right? So this is what is actually represented in vectors, and this is something which you are going to see what happens when we do it geometrically. So we basically have two kinds of additions in geometrically. One is called polygon addition, and then we got the triangle method. So what we are going to see now is the triangle method. So whenever you are considering a vector, let's say you are going from your home to a shop, your home would be your point of origin. So there is always a point of origin which is being considered here. So what we have here is the vector A, which actually represents it. Okay, so if we just consider this A, this is the vector which is representing, and it is a length. Okay, some kind of length. So this is your origin. So this center is basically your origin here. So this is your origin. Okay, you are starting from here and you are going to the shop at this particular point. Okay, so you have it here. So what happens is you will first draw the vector with respect to the origin of some length. Okay, with respect to the x and y coordinate. Now, real life, it's not like the ideal condition that you go along the x-axis or y-axis. You can go in any direction, right? It will be basically with some angle with respect to x and y-axis. Okay, so this will actually specify the direction, and that's why the coordinate system is very important. When we go into like higher classes and all and do more of physics, there are coordinate system which we should know. Here we are considering for now as the x and the y coordinates. Okay, so please I think these things you have come across, x and y. These are basic geometry, and this coordinate system is called the Cartesian coordinate system. Is it right? Okay, so Cartesian coordinate system. So right now we are just going to concentrate on the Cartesian coordinate system. Now suppose you are going to this particular point and you actually go for another region. Okay, so let's say you are at the next point, this will be your starting point, and you are going to another point here. Okay, and then this vector is B. So this B is representing that particular length. This A is representing the initial length. Okay, so this is very simple. Now you want to find out what is your net displacement. So obviously we are going to join the starting of the point of A and the ending of B, right? Starting of A, ending of B. So this is actually representing A plus B. The thing is, what happens is if you measure this length and if you measure this length and if you measure this length, you will see that this particular length that we are considering is nothing but A plus B. This is nothing but A plus B. Okay, so this is something which is important. So this A plus B is called the resultant. So you might be hearing to a lot of terms which is basically called resultant in vectors. Okay, so this is resultant. It depends on what kind of representation you are using. Sometimes it is used as R and all. Basic derivation it's always R. So this is a resultant. So what? How do you find the resultant? The resultant is basically nothing but from the point of origin of A bar to the end of the last vector bar. So you start from A bar and you end at the last point of B bar. So this is basically nothing but your triangle method. Is it there? Okay. So this is actually simple. We are just considering the direction and we are going to look into other points. So we are going to look into more complex problems now. So let's go for this. Okay. So suppose I don't have only one point. Okay. I go from A to B, B to C, C to D, D to E, and so on. Okay. Can I find out the resultant? The logic remains the same. You are just going to take the beginning of the first point. Okay. So you are just going to take here the beginning of A. I'm not doing the coordinate system here, and the ending, okay, ending of the last point where you're moving, and then you are just going to join it. So what happens is you are going from this point to this point, and then you are going from this point to this point, this point to this point, this point to this point. Now until now, till your class 10, these things were very simple. It's like I know that the distance, the displacement is directly correcting the initial and the final point. But now, since you have to do a lot of maths, you have to solve numerical problems, you have to understand it in terms of maths, okay? And that's why we are using vectors, scalars, and so on. So I think this diagram is also very simple. We stopped here. So what I meant here was very simple, that as we go from one point to other point, and then there can be numerous points in between, we can always have a single resultant with a combination of the addition of all these, right? A, B, C, and D. So in general, if we actually talk about this and we want to do it individually, what you can do is this. Okay, somehow my slides are not changing. This way. Yeah, so if I do this, I can go from A, then to this point, then to this point, and then I can do a triangle law of addition. And then again, I can go for the next point, and again, I can do the same, right? And then finally, I can arrive at the resultant. Okay, so at each of these points, we can actually have some vector representation for that. Okay, so this is what is being shown. So this, if we consider, this will be nothing A plus B plus C. I think is very clear. This is A, this is B, this is C. So if you are drawing a result vector here, this is A plus B plus C. On the other hand, if you just draw here, it will be nothing but A plus B, right? Okay. So next we have got something which we call as the polygon method. Okay, so when you look into the diagram of your book, it's actually simple, but I'll explain it in a very simple way. I'm not going to go through the sentences. So basically what happens here is the same thing. You have a vector A which starts from the origin, and then you might have a vector B which also starts from the same point, right? Until now, what we have seen was that whatever was the ending of A was the beginning of B, right? Something like that. Now what we are saying that both A and B are actually starting from the C point or the origin, right? So then if that is the case, what happens to the resultant? So in polygon rule, what it says is that we can actually make a polygon out of it. So here we are basically making a quadrilateral. We are having four sides, right? Yeah. So this is basically the parallelogram law. Okay. So what happens is you might have n number of sides. Okay? So you can use this law in order to deduce vectors which are there are more. Let's say it's not A, B, there's A, B, C, D, and so on, right? There are a number of vectors starting from the origin. You can use the same. But as an example, we are just taking it to be A and B. So when we basically take A and B, you can see that opposite to A, we can draw another vector, right? And as we have seen in the previous slide, that if we trace the vector A to another position, and if there is no change in direction or length, the effect will remain the same. So what we did here was we took this A from here to this particular point, and this B here to this particular point. So we basically have two equal vectors at two different positions, right? and this actually makes a parallelogram, correct? Now I want to find out the resultant. So what happened was that when we took, suppose this vector and this vector, joined it, correct? But here we have to do something additional. We don't have this vector and this vector. We have this vector and this vector, both are starting from the same point. So for that we have to do a transverse, and we actually have to move the vector from this end to this end, and this vector A from this end to this end, and make it a parallelogram. So once we make the parallelogram, we can definitely draw the diagonal, right? And this diagonal will actually represent the resultant vector. Okay. So you can understand it from here that if we basically just consider a simple case, something like this, and we just draw a diagonal here and we write down a plus b, we might be confused, right? Why the resultant is an addition, and that is why we use actually the parallelogram law, because parallelogram law says that we can actually make a parallelogram out of it without affecting the magnitude or direction of the vector, and then we can actually draw the diagonal and find out what is the resultant vector. Okay. And in this case, the resultant vector is a plus b is same as that of b plus a. Okay. So we have to take this into consideration. So what happens is, if you're solving some numerical problems, you want to represent something in terms of a figure, you can actually do it in this way. Let's say A and B are two friends, or let's say X and Y are two friends. They are starting from home, one going towards one direction, the other is going towards the other direction, right? So these kind of questions can be tackled by doing these kind of diagrams. Okay, very simple. Next, what is vector subtraction? So, when we talk about math, subtraction is only a special case of addition, you can say. We are adding a value, only the negative value is being added, right? So this is what is subtraction in vector is also, it's the same. We have, let's say, a vector A, and we have a vector B, correct? Now I want to find out the resultant. I can simply just join this and find out the resultant, right? If we join these two, you can find out the A plus B, correct? But then both A and B should be in the same sense, means they are moving in the same direction, right? So we have this. Yes. Okay. Okay, so the ending point of A and ending point of B are in the same point. So you see that if I draw it in this way, that this is here and B is here, and then B goes in this direction, right? Okay, suppose this is the case, then what happens is, suppose this A is of, let's say, magnitude 5, and let's say the B is of magnitude 10, right? And herein comes the concept of negative vector. So the total magnitude will be 5. So the resultant won't be A plus B, but it will be rather A minus B. We can take a mod of that because we are just taking the magnitude. Correct? So this is what is happening. So that is what is I'm going to show in the next point also. So you write that if they're exactly in the opposite direction, they might not be exactly at opposite direction, but they might be something like this. They are in opposite direction, but they are making a different angle, right? So this will become minus B now. Why? Because if A starts here and ends here, okay, B is at a point, or the ending point of B is at a point which is ahead of A. See, this point is basically ahead of A, right? So that means these are nothing but more or less in the same sense, same direction. But if you consider negative, you see the ending point of A and the ending point of B, if you compare, you see that the ending point of B is behind A, right? And hence we actually use the concept of vector subtraction here. So in this direction it is plus B, this direction it will be minus B, right? And here also we are going to find out the resultant and we are going to add. So we are going to find out the resultant here and we are just going to add. But in this case, B is not B, B is minus B, right? Because the ending points are behind. Okay, the ending point of A is B is behind the ending point of A. So this is what is the result. So that's why we write it down as A minus B. Correct? Okay. One more point that I like to just point here, that that whenever you are actually drawing the resultant, make sure that your direction of the arrow, in this particular arrow, should always point from the starting point of the first vector towards the ending point of the second vector. Okay, it can never be in this direction. Okay, it can never be in this direction. You should not write that. Okay? So this notation has to be taken care of. Very important. Okay, if you write it down in this direction, then you have to put a minus here, and then you have to give a bracket here. Okay, so these things will come logically when we actually are doing more and more numerical problems. Okay. Okay, so then what are the different ways of representing vectors? So as I said that there can be Cartesian coordinates or polar coordinates. Okay, so if you are representing a vector, let's say this is your vector r, right? And you see this vector is inclined at an angle theta with x-axis. Okay, so which is nothing but 25 degree, correct? And then if you consider with y-axis, what is the angle with respect to y-axis? Can you tell me? What will be the angle with respect to, not 90 degree. I am talking about the angle of r with respect to y-axis. It will be 90 minus 25, right? Because x-axis and, sorry, just go back. X-axis and y-axis, okay, are at an angle of 90 degrees. So this is 90 degrees, this entire one, right? Correct? But this angle is not 90 degrees. This angle is 90 minus 25, right? Yeah, so it's around 65 degree. So this vector r, which is basically sometimes known as position vector of a point, let's say P, this is point P, position vector of this point P. That means this vector r will represent at what point the point P is. Okay, and at what angle it is inclined, and we have to find out this. So that means there are two things here, one is r and one is theta, right? And these are nothing but what we call as the polar coordinates. Heard about polar coordinates before, right? Okay, so then this is the line phase. Here you are actually going to know about another kind of coordinate which is called the polar coordinate. Okay. So you see here, suppose I want to find out this particular position, I can go along x-axis, let's say a distance of 1.36 meter, right? And then from x-axis, I can actually go upwards towards y-axis and I go a distance of 0.634 meter. And then I can reach this point, right? So that means I am representing this point in terms of x and y. Is it correct? X, and then this is y. This comes from basically from geometry. Okay? This is x and this is y, correct? So what is my x value? 1.36, and what is my y value? 0.634. Right? What is this? This is called the Cartesian coordinate system. So this is one way of representing the point, right? But then if you basically have an origin, you can also represent it in this way. I can actually directly draw a straight line and I can take the magnitude of that, which is nothing but r. Okay, this r is nothing but 1.50 meter, correct? And then I can say that if I just write down r 1.50 meter, this is still not the complete information because I don't know at what point it is. I can go r is equal to 1.5 meter along this direction also. I can go along this direction also, but the actual point is here, right? So how do I know it? I have to define the angle also. That means at what angle with respect to x-axis is r is equal to 1.50 meter, correct? Logical? So if we use that idea, we can also find out the point P. Now this point is not represented by x and y, this is represented by r and theta. Okay, and this is called your polar coordinate. Okay, this is called polar coordinate. So this is important. So this is also a way of representing them. Okay, so I will give you some conclusion at the end. But before that, something which is very important is called component of vector. Component. Okay, so in general when we say anything as component means it's a part, correct? It's basically a part. So what do I mean by component here is that I have a vector A which is moving at certain angle theta along the x-axis, right? Can you see this diagram? So That means that if it is moving at an angle theta with respect to x-axis, it will have some movement along x-axis, distance it has covered along x-axis, right? And some distance it has also covered along y-axis, correct? So it has covered a distance along x and y axis. The question is how much distance it has covered along x axis and how much distance has it covered along y axis. For that analysis, we use something which is called the components. Okay, and so the component is nothing but the projection of the vector. Okay, this is only a technical term, don't think it's very complicated. This is basically the projection of vector along x and y axis. It is very much logical. That means if you consider this is the length of the vector, okay, how much length it has covered along x axis and how much length it has covered along the y axis. So that means if I write, yes, that is exactly what we are coming to. So you basically just consider something like ax, it will represent how much distance it has covered along x-axis, and if we write down ay, it will say how much distance it has covered along the y-axis. So that is the representation. Okay. And then how do we find it? That is the important question. So what happens is, suppose, so this is what is called projection. In general, if you understand the term projection, I think it's something like a projector projecting an image, right? So here also it's the same. So what happens here is that you have this is your A, this is your A vector, and then I want to know how much distance it has covered along the x-axis. So what I do is, this is your projection. So if I know the angle theta, then projection would be always nothing but vector terms of cos theta. So that means ax would be nothing but magnitude of A, you can consider, okay, magnitude of A, okay, this is the magnitude of A, okay, and then we can take cos theta, okay. So this is A cos theta. Similarly, on this side it will be nothing but A cos of 90 minus theta, okay. Sometimes what happens is, if some people say, they say, okay, this is along x-axis, along y-axis it will be nothing but A sin theta. But it's better to understand that this is not sin theta. Both the sides the projection is cos theta only. Okay, both the sides the projection is cos theta. Okay, projection is cos theta. I'll basically take a arrow. Yeah, so both the sides the projection is cos theta. Only that it is this side. What is the angle here? 90 minus theta. I told you in the previous slide, right? So this is 90 minus theta. So this is A cos 90 minus theta. Okay, and this is nothing but A cos of theta. So A cos of theta would be there, and A cos 90 minus theta, from trigonometry it is nothing but sin theta. Hence, one side it is A cos theta, the other side it is A sin theta. Okay, but please make sure, so that you don't get confused here, don't remember it in terms of A cos theta and A sin theta. Always remember it in terms of A cos theta only. You have to just know what is the angle with which it is inclined. If A is inclined at an angle, let's say 60 degree with this side, you can simply write it down as A cos 60 degree. Okay. And if this side it is 30 degree, you can simply write it as A cos 30 degree. Okay. In general, you can always write down sin theta and cos theta if you know what is theta. That is always possible, but I'll depend on what kind of problem we are doing. So that's why I've just gone for this particular slide. So you can see that you've got A here, okay, and then it reaches up to this particular point. So what is its displacement along y-axis? This much, right? This much along y-axis. So if this is the vector, I can translate the vector and put it on this side. It is the same thing, right? Correct. So that means this will actually be the perpendicular side. Okay, this will basically be the base, and this will be nothing but the hypotenuse. So is it becoming a right angle triangle now? It's becoming a right angle triangle. Correct. Here this will represent the magnitude along the x-axis, and this will actually represent the magnitude along the y-axis. Okay, right. So this angle is your 90 degrees. So this is a very simple diagram, correct? So what happens is, the x component of a vector is the projection along the x-axis. So what is this x component? X component is nothing but the projection along the x-axis. Now what is cos theta? Okay, it is nothing but base divided by hypotenuse, right? Or more specifically, adjacent side by hypotenuse, right? So always remember it in terms of adjacent side, means the side which is adjacent to theta. Okay, So this is your theta. So this is your adjacent side. So this is an adjacent side represented by AX. AX is the length, magnitude. So that means it is AX. So it is adjacent side divided by hypotenuse. So hypotenuse is A. Here we are not considering the vector because we want to find out what is the value of theta, cos theta, right? So that means in simple words, we can say that AX is equal to A cos theta. And that's why in the previous slide, I've done just use the shortcut. Okay. Just simple words, we have considered this as A cos theta. But how it is A cos theta is because of this. It's because of this. Okay. So you can see this cos theta is equal to AX divided by A. That means it is nothing but hypotenuse, adjacent side divided by hypotenuse. So it is nothing but cos theta AX by A. So AX is equal to A cos theta. And that is why it is A cos theta AX. Okay. The thing is, you don't know what is AX, but you might know what is the angle of inclination. You might know what is the magnitude of the vector A. Then you can easily find out what is AX, right? So that is the application if you do math. Similarly, along y-axis, if you consider you want to find out this length, so you can use sine theta. Sine theta is nothing but opposite side by hypotenuse, right? Okay, or in layman's term, it's perpendicular divided by hypotenuse. So let's say opposite side by hypotenuse. So it is AY divided by A. So AY is equal to nothing but A sine theta. A is equal to A sine theta. Correct? So you know what is AY and what is AX. But the thing is, if you think about it in terms of vector, and if you use the parallelogram law, you know that you go from here to here and here to here, and this is nothing but equal to A. You can think about triangle's law also. Since I have translated the vector from this end to this end, I'm talking about parallelogram law. Okay, you can draw the diagonal. Or in general, we can say it starts from here and ends at here. So this distance is AX and AY. So that means A is nothing but AX plus AY. A bar is equal to AX plus AY bar. Is it clear? Yeah, so concept is very simple, but then it always depends on the angle, okay, and that is why this cycle is important. So basically, this rotation might be 360 degree, okay, it might be in any direction. So it might be theta, and theta is anything which is arbitrary. It might be 90, it might be 60, it might be 120, and so on. So what happens is, this is very simple. If theta is zero, what it means is this. If theta is 0, that means this A is not along an angle with respect to x. It is exactly along the x-axis. Correct? So if theta is 0, it is exactly along the x-axis. It simply means that there is no y component. That means there is no displacement along y-axis. Correct? So if there is no displacement along y-axis, AY will become 0. Simple. Because what is AY? AY is nothing but cos, right? You can write down simply it as A cos of this. What is the angle? 90 degree. Yeah, so AY is A sine theta. But what we see here is that with respect to y-axis, there is no component. So what is this angle? 0, right? What is sine 0? 0, correct? So that means AY is 0, but that is mathematically. But if you just look into it analytically, you see that the vector is moving only along x-axis. There is no angle with respect to x-axis, right? So that means the vector has no displacement along y-axis, correct? So that means if there doesn't have any displacement along y-axis, the component along y-axis would be 0. And the entire vector will be only along x-axis. So entire vector is only along x-axis. It becomes more clear when we actually slightly rotate it. Now you make it theta. Suppose it's say exact the center. That means let's say theta is equal to 45 degree, correct? So that means the effect along x-axis would be nothing but A cos of 45, which will be greater than 0, obviously, because cos 45 is nothing but 1 by root 2, and you can actually look at the table of trigonometry there. And then along AY also, it is nothing but A sine 45, correct? And you know A cos 45 and A sine 45 are both same, 1 by root 2. And A is the same vector, so that means whatever displacement is along x-axis, the same equal displacement is also along y-axis, correct? So that means if I actually draw these lines, okay, it will basically become a square now. So I directly just draw a line here, it will become a square. Sorry, this is not a square. This is a square, right? Okay, so this will basically become a square. So then what happens is, let's change the angle a bit more now. Now obviously if we just go for, let's say, 90 degree, we see that the displacement is only along x-axis, oh sorry, y-axis. Now there is no displacement along x-axis now, correct? So that means now the x component will become 0, but a will be equal to a, correct? You can look into it mathematically, but also think about it analytically. Okay, so this is important. So next what happens is, let's change the angle and let's increase. So now this angle is, let's say, 135. Now you see why it is 135. I hope it is clear. We always basically take from the origin. So we always take it from this. So if it was this was 90 degree. From here what happens is, if you really consider this is the angle that we are considering, right? And this is obviously greater than 90 degrees. So this is nothing but 135 degree. Then you can again do this cos of 135, and this would be nothing but sine of 135, because if you basically consider this is if you look at this here, okay, what is the angle that this is making with the y-axis, and what is the angle that is making with the x-axis? With the x-axis, this is basically making an angle of 135. With the y-axis, it is making an angle of 145. This angle is 45, right? This angle is 45. So that means this is nothing but, if I consider cos theta, this would be nothing but a cos of 45 degree, correct? A cos of 45 degree is same as a sine of 135 degree. Okay? Because here you don't have this angle, okay? Please get confused here. You don't have this angle. If you have it something like this, you basically say 90 minus of whatever is this angle, right? But here it is increasing, so it is 90 plus of this, correct? It is 90 plus of this, it is 90 plus 45, and that's why it is nothing but a sine of 135, not minus, because it's going in the other direction, correct? So I'll give you the slide, you can obviously think about it, okay? And then this will be very easy. And then let's go to the other direction, and then it becomes 180. And then I'm not going to explain this. This is very simple. Okay, we can actually keep on rotating and think about it. Okay, so what I want you to do is, as a task, that you can actually think about it, that how exactly this becomes. So I have given you entire 360-degree rotation. Okay, and you can always remember all these angles. Okay, this is not going to be very difficult. So look into the quadrant. Okay, I think quadrant is also a term which you might not have heard a lot of times. Okay, but in general, if you consider something like a quadrant, there are 4 quadrants here. Okay, these are 4 quadrants. This always is written in this way. Okay, some math, some geometry has to be clear to us. So this is your first quadrant, this is your second quadrant, this is your third quadrant, this is your fourth quadrant. Okay, so quadrant always goes in this way, in the anti-clockwise direction. Okay, so in the first quadrant you will see that both ax and ay are greater than 0. Why? We already have the answer, the yes that we have. And the second quadrant, ax is less than 0, ay is greater than 0. In the third quadrant, both ax and ay are less than 0. In the fourth quadrant, ax is greater than 0, ay is less than 0. So what I want is, you can also revisit your trigonometric table. Okay, if you look into your trigonometric table, you might be able to revise these things. Okay, just look into these things. I'll also make a table and probably show it to you the next. Okay. Now what happens is, if I suppose I don't know what is theta, I am not aware about theta, I just know what is a, can I find out what is angle theta? Okay, so what happens is, if I want to find out the magnitude, what I have to do is, I have to take a root over of ax square plus ay square. So suppose I know what is ax now, this is a cos theta, and I know what is ay now, which is nothing but a sin theta, right? Now I want to find out what is a. So a vectorially would be nothing but ax plus ay, correct? But then I am not interested in finding out the vector addition. I am interested to find out what is the magnitude of ax and ay. So finding out the magnitude, I am going to, this is don't get confused here. So if I know the magnitude of a vector, I can also find out what is the angle of the vector is in the same direction. So what was tan theta now? Okay, so tan theta is nothing but opposite side. Okay, opposite side divided by adjacent side. So it is not that height base, so perpendicular divided by base, right? So perpendicular base, so that means it will be nothing but ay divided by ax, right? So this is tan theta, and if I use the inverse table, I can find out theta. So theta is equal to tan inverse of ay divided by a, right? So this is important for numerical because there will be a question where they will ask you to find out the magnitude and the angle at which the vector A is inclined. Correct? So can we just which one? This particular case? Yes. In general, what you have to do, you have to know what is your AX and AY. See this. What is AX basically? AX is a cos of theta, right? So you are going to replace it with a cos theta here, and then you are going to replace it with a sin theta. And then if you just open the bracket, it will be a square cos square theta plus a square sin square theta. Okay, you're getting it? Okay. So it will be nothing but okay, so this is going to take some time. So you can take out a square common, correct? You can take out a square common, and then there is the root, of course. If you take a square common, within bracket it is not sin square theta plus cos square theta. Is it correct? Yeah, right. So now you know. So if this is a square sin square theta plus cos square theta, what is the value now? Which is 1, right? So yeah, correct. The root there. So what is the answer? You're getting the magnitude. You're getting the magnitude, correct? Yeah. So the thing is, if cos square theta and sin square theta in general we are talking about here, okay? We are not saying that theta is 90 or something, because what happens is if theta is 90 here, then it will become, will have to this will become only a, right? Because sorry, this will become 0. So cos 90 is 0, correct? And this will become a. So what is your answer? Final answer will be a again. If you replace it here, it will be a, right? Okay. And then if you just change the reverse it, let's say it's 45 and then a cos 45 and a sin 45, you are again going to get a only, correct? Right? And on the other hand, if you do it, let's say cos is 30, it will be a cos 30 plus a sin. So what I have here is that this theta will remain as the same value. This theta always remain as this theta, right? So if this theta will be plus this theta might be 10, 20, 30, 40, whatever. All the so you can always replace the value and find that out. Okay. So we will do one problem here. But anyway, before we just finish, we have so first thing first is we have already done this. We have this a is equal to a plus ay, and then how do I represent it in terms of vectors? Or we never write down something related with I cap. That means we are representing the vector along the x direction. What is I cap? I cap is a unit vector. That means it is not going to have an effect on the magnitude. Okay, it is a way to represent the vector. So whenever there is a cap, okay, whenever there is a cap, something like this, it is always a unit vector. That is why we call it as I hat, j hat, or k hat, or cap, or whatever. So whenever you have something related with I cap, if you write down a I cap, it automatically represents that ax actually a vector which is along the x direction, because I cap represents the x. Clear? Similarly, A will represent the y direction and Z will represent the direction. Okay. So these unit vectors always used to specify the direction, nothing else. So you can just simply write down as ax bar, or you can simply write it down as ax represent magnitude. Ax will represent the magnitude, okay, and this I cap, j cap, and so on, it will represent b vector. Okay. So whether it is a plus or a minus, in the same direction, in the same sense, or it is in the opposite sense. Okay. So this is what is a representation of sign. That we will see into a problem. Unit vector will always have a magnitude of 1. So if this is having a magnitude of 1, when you multiply it, you get the same value, right? Ax, right? So there is no effect on the magnitude. So the unit vector should be such that the magnitude will always remain as 1. So I say this is along direction, this is along b direction, and this is along k direction. Very important. Okay, so if we just look into this vectorial, we have got two vectors. Let's say A, and then this is a vector Ax. So Ax can be represented as this much, which is nothing but Ax into I. Why I? Because it is representing along the x direction, and then this is nothing but along the y direction, which is represented by j. So it is Ay into j, right? So I don't write down Ax bar plus Ay bar. I can also write it down as Ax I cap plus Ay j cap, where I cap and j cap represents the direction along the x and the y axis respectively. Correct? So you might have another vector, let's say b. Okay, so if you consider another vector b, it will be might be bxi plus byj. You can relate to the diagram, but in general I am saying that if I want to find out what is, I'm going from a to b and from here to here, I want to find out what is c. I want to find out the resultant vector. So mathematically what I can do is I can simply add this with this. Correct? If I add this with this, I can take out I common, I cap. That means along x-axis, the net displacement in magnitude is Ax plus Bx. And along y-axis, it is nothing but Ay plus By, because j component and I component I am adding up. Correct? So in terms of magnitude, what is along C? C is nothing but Ax plus Bx. Along y, it is nothing but Ay plus By. Right? So this is actually very simple. It's just like this figure probably is there in the book. It will look very complicated, but the concept is very simple because we have already studied what is the basics of this. Okay. So if we just take an example, let's say, and this is basically nothing but dealing with operation with vectors. So we have got a vector A. Okay, we have got a vector A which is represented by this 3 minus 3 and 5. Now what does it mean? We have to analyze this. It means it moves along the negative x direction by a distance of minus 3. I don't know the unit. I just say by magnitude minus 3. Okay, and along y axis by a magnitude of plus 5. Right? Very simple. So that means if I actually draw a curve here, and then that means that it is going to go along a direction of this. So this is my minus 3. So this is minus 3, and then along y-axis it is going to go a distance of, let's say, so this is, so if I just join these 2 points, I'm going to reach the vector that being represented here, right? Very simple. So similarly with B also, we have got one more vector B, which is actually represented by 4 units along the positive x direction and minus 2 along the negative y direction. So if I want to represent it in this way, I know that, yeah, 4 quadrant, right? Yeah. So we have that. Okay. So what we have this here is C minus 3i plus 5j, correct? Why minus 3? Because the magnitude is minus 3. Okay. And then when we write it down in terms of Cartesian coordinate, the first bracket term would be always be x, and the second bracketed term will always be y. Correct? So that means this is representing movement along the x direction. That's why we're representing this as I. Sorry, we're representing it as I. And this is 5 magnitude, and this is represented as j because this is along the z y direction. Right? Similarly, we can also represent what is b. The question is, you have to find out the magnitude and the direction of C. Okay. So but know that C is nothing but A plus B. Correct? Whether it is in the negative direction or in the positive direction is taken care of by the symbol that is being put. So if the minus is there, I don't need to reconsider the minus again. Okay, sometimes we get confused with vectors. If we are only looking into the diagram to write down the sign, then only we need to consider the minus sign and all. Okay, but here the minus sign is already given. So what we do is we simply add C is equal to A plus B. Okay, and that will actually give the vector representation, So if we take C is equal to A plus B, what happens is, so if we have A along this direction, okay, this is already there in the animation, and B along this, okay, B is this, and then what happens is we actually find out what is the resultant C. So the resultant C, we can actually just put it here, and we can put it here, and then we can actually use the parallelogram law and then find out what is C. Okay, even if you don't consider the diagram, C would simply be nothing but A plus B. So if you just write down A plus B, what is my A? A is minus 3 plus 4 into I, and then this part it will be my 5 minus 2 into J. Simple, you can add these two, right? You can add these two. I can be taken common. So if you take I common, this is minus 3 plus 4, and if you take J common, this is plus 5 minus 2. So plus 5 minus 2, this is J. So what is the answer? I plus 3J, right? Y plus 3J. So that means that along x-axis, the Cx value is 1, and along y-axis, the Cy value is 3. Okay, so that means the magnitude is 1 and 3 along x and y-axis. Is it clear? So once we know along the magnitude along the x-axis and the y-axis, okay, can we find out the angle? Yes, because we already know what is theta. And can we find out the magnitude of C? That can also be found out. Okay, so if we just go back, okay, if you remember this. So if we just go back here, we have already seen what is the magnitude and what is the angle. So what we have to do is we have to use this particular formula. Okay, so this formula we have to use here. So we have this. Okay, this one not that. Okay, there's too many slides here. Okay, so we have this. This is your magnitude. Okay, this is your magnitude, the formula, and this is the formula for angle, right? So if you want to find out the magnitude, you should know what is the value along the x-axis, you should know what is the value along the y-axis. Correct? So for doing that, what we are going to do is this. So for this formula, we are using this. So we'll be using this formula. You have to remember it as a thumb, because when you go for entrance and all, you have to definitely do it in short. So C square which take this one square and find out what is the this is never it with the side. So if Cx by C, we can inverse of 3, and then use the inverse table, or you can use the calculator. You know what is the angle? Actually, to school examination, you do get the table. So what I will do is in the future classes, I will know how to use the table and also tell you how to actually do it using the calculator, because some of the functions are needed to know when you use a scientific calculator. Don't worry, they are not going to give you a problem where this is not standard. Suppose this value is given to be 45, then you can actually find it out. The standard. Don't ask standard. What you will do is basically they will give something which is, let's say, a calculator or table, or the table or the calculator is not provided, you can straight away leave it at tan inverse of 3. That's perfectly fine. Okay, this is just an exact answer which has been found out. Where there are no calculators or something which is allowed, they usually don't give you these complicated things. Okay, they probably will give you a value as, let's say, 1. Okay, so if you go to the 10 table, you know 10 0 degree, 10 30 degree, 45 degree, and so on, right? Right. So you know 10 45 degree is so on. So this was all that actually I wanted to tell you about this. I think more or less covers a chapter. Okay? So a lot of topics to cover. I have taught you something which is new, is something which is the polar coordinate. Okay? So polar coordinates will be nothing but represented in terms of the r and theta and so on. It will be so current coordinates nothing but to write it down in terms of x and y. Simple. And then unit vectors you can write it down as a y, as z. Okay? Included z because there might be cases that become more complicated than the z exists. Okay. But in that case, the angle of inclinations will be different. But we have and then do the distribution law and so on. So these things so I thought this was clear to you because we have actually done a lot of things and I